This video is about the differentiation of inverse hyperbolic functions. The process is quite similar to the differentiation of inverse trigonometric functions. The differentiation formulas are shown. Please don't mind these restrictions whenever you use these formulas. These are just the domain of the functions given. Now let's go straight to some examples. Let's find the first derivative of the following functions. Number 1, y is equal to arc hyperbolic tangent of 1 over x squared. So this function is in the form d31, where u in this function is equal to 1 over x squared. Okay, we can also write our function as y equals arc hyperbolic tangent of x raised to negative 2. So in this case, u is equal to x raised to negative 2. So when we get du later on, we'll just use the power rule for the derivative of x raised to negative 2. So let us answer this. The solution, y prime, using d31, it's du, so it's the derivative of x raised to negative 2 over 1 minus u squared, x raised to negative 2 squared. So we'll continue by differentiating x raised to negative 2, and the derivative is equal to negative 2 x raised to negative 3. So over 1 minus x raised to negative 2 squared is x raised to negative 4. Okay, now simplifying our answer by making all the negative exponents positive, we'll have the numerator as negative 2 over x cubed, and the denominator as 1 minus 1 over x to the 4th. Okay, now this is a complex fraction that we need to simplify. Okay, we'll take the LCD in the denominator first between 1 and 1 over x to the 4th. So I'll copy the numerator negative 2 over x cubed. The denominator, LCD in the denominator is x to the 4th. And we'll have x to the 4th minus 1 here. Okay, so continuing, we'll have y prime equals negative 2 over x cubed times the reciprocal of the denominator, which is x to the 4th over x to the 4th minus 1. Okay, now x to the 4th divided by x cubed is just x. Alright, so we'll get y prime equals negative 2 x over x to the 4th minus 1. This is the derivative of the function. Now for next example, number 2 is y equals arc hyperbolic sine of tangent x. So I have the formulas on the right side of the screen. This is in the form arc hyperbolic sine of u in d29, where u in this case is tangent of x. Okay, so we get y prime. Y prime is equal to, according to the formula, du, so that's the derivative of tangent of x over the square root of u squared. So that's tangent of x squared plus 1. Okay, let's take the derivative of tangent of x, which is secant squared x, as we have learned previously. So that's over the square root of tangent squared of x plus 1, where tangent squared of x plus 1, according to a Pythagorean identity, is secant squared of 1. Of x, I mean. So square root of secant squared of x in the denominator, when simplified, is just secant of x. Okay, dividing secant squared x by secant x, so you'll have secant x in the numerator, and so y prime is equal to secant x when simplified. This is the derivative of the function. Okay, this is example number 3, y equals arc hyperbolic cotangent of cosine of 2x. So this is in the form d32, okay, where u is equal to cosine of 2x. This is u. Okay, so y prime according to d32 is equal to du, so that's the derivative of cosine of 2x over 1 minus u squared, where u is cosine of 2x. So we square cosine of 2x. So y prime, getting the derivative of cosine of 2x, that's negative sine of 2x times 2. So over 1 minus cosine squared of 2x. Where according to an identity, a Pythagorean identity, 1 minus cosine squared of 2x is sine squared of 2x. So y prime is equal to negative sine of 2x times 2 over sine squared of 2x. Okay, now dividing sine 2x by sine squared 2x, we'll be left with sine of 2x in the denominator. So that's negative 2 over sine of 2x. But 1 over sine of 2x is cosecant of 2x. So simplify our answer further. Y prime is equal to negative 2 cosecant of 2x. This is the derivative of the function. Function in number 4 is in the form d30. Okay, this is y equals arc hyperbolic cosine of a over x. So if we are to differentiate with respect to x, then we have to take a as a constant. Okay, we can also write the function as y equals arc hyperbolic cosine of a times x raised to negative 1. Remember that a is just a constant. So when we differentiate a x raised to negative 1 later on, we'll just use the power rule for the derivative of x raised to negative 1. Okay, so y prime according to d30 is du, so that's the derivative of a x raised to negative 1 with respect to x over the square root of u squared, where u is ax raised to negative 1, so squared minus 1. Okay, we'll just simplify our answer and get the derivative of the numerator. According to power rule, that's negative, so a is just a constant, so just copy a, and then the derivative of x raised to negative 1 is negative x raised to negative 2. So over the square root of squaring a, you get a squared, squaring x raised to negative 1 is x raised to negative 2 minus 1. Okay, simplifying our answer by making all the negative exponents positive. So the numerator is negative a over x squared. And the denominator is square root of a squared over x squared minus 1. Okay, so taking the LCD in the radicand, we have y prime equals, so that the numerator is still negative a over x squared. Okay, in the denominator, we have the radical, and in the radicand, we have the LCD x squared. So the numerator would be a squared minus x squared. There you go. And then this can be taken out of the radical sign because square root of x squared is just x. Okay, so y prime is equal to negative a over x squared over the square root of a squared minus x squared over x, as we take x squared out of the radical sign. And then getting the reciprocal of the denominator and then proceeding to multiplication, we'll have negative a over x squared times x over the square root of a squared minus x squared. Now we can divide x and x squared and get 1 over x. So our final answer would be y prime is equal to negative a over x times square root of a squared minus x squared. Right, this is the derivative of the function. Example number 5, in our last example, y equals arc hyperbolic secant of square root of 1 minus x squared. So this is in the form d33, where u is equal to square root of 1 minus x squared. Okay, so y prime according to d33 is equal to negative of du, so that's the derivative of square root of 1 minus x squared over u, where u is square root of 1 minus x squared. Okay, times the square root of 1 minus u squared. When we square root of 1 minus x squared, we'll just get 1 minus x squared. Okay, so it's 1, the radicand is 1 minus the quantity 1 minus x squared. Okay, take the derivative of the numerator using power rule. Okay, generalized power rule for the numerator and then simplifying the denominator will get negative of, so the derivative in the numerator is 1/2 of 1 minus x squared raised to negative 1/2 times the derivative of 1 minus x squared, which is negative 2x. So over the square root of 1 minus x squared times the square root of 1 minus 1 plus x squared. So 1 minus 1 here is 0. And then we have square root of x squared left. Alright, so simplifying the numerator, we'll have 2 over 2. Okay. And then we have two negative signs, as we can see. So when we simplify the expression, y prime is now positive. X times 1 minus x squared raised to negative 1/2 over the square root of 1 minus x squared times the square root of x squared. Now simplifying this further, making the exponent in the numerator positive, we'll have x over 1 minus x squared raised to 1/2 over the square root of 1 minus x squared times square root of x squared is just x. Okay. So simplifying further, we'll get y prime equals x over 1 minus x squared raised to 1/2 is also square root of 1 minus x squared. Okay, taking the reciprocal of the denominator and multiplying by the numerator, we'll have 1 over x squared of 1 minus x squared. Okay, now simplifying, dividing x by itself, we get 1. And then when we multiply square root of 1 minus x squared by itself, we get 1 minus x squared. And well, that's y prime equals 1 over 1 minus x squared. This is the derivative of the function.